My name is Amobude Ekia Kelly. This is my dissertation presentation. My topic is data visualization dashboard for COVID-19 task force and evaluating the use of machine learning models for predicting the outcome of new deaths with COVID-19 vaccination programs. So the aim of this research is to create a data visualization dashboard for COVID-19 analysis that is simple to use and simple to understand, as well as developing a decision support system that analyzes the margin of error in determining the most effective machine learning model for predicting the outcome of new deaths in relation to vaccination programs. So the objectives of this research or this study is to carry out exploratory data analysis and provide a visualization overview of the COVID-19 pandemic trend and pattern in the UK, to evaluate COVID-19 vaccination and population data sets and features, and carry out data transformation and pre-processing to determine the machine learning tasks to use that we perform in data, whether it's regression or classification, and also to develop different machine learning models for predicting the outcome of new COVID-19 deaths in relation to COVID-19 vaccination program, and lastly to identify the best performing machine learning models by evaluating the performance of the developed model. The methodology I used was the CRISP-DM methodology. So the CRISP-DM stands from the Cross Industry Standard Process for Data Mining. So I did business understanding, where I talked about my goals, my objectives. So data understanding, where I had to go collect the data preparation. It involves cleaning the data, managing data, then data modeling, where I had to import the machine learning models, then evaluation of each of the built models, and the last stage of the CRISP-DM is deployment, but I did not deploy, which is deployment. Then this is my project plan, which include the draft proposal, the ethical approval, the data acquisition, which was the collection of data, the processing, exploration, the feature selection, where I looked at correlation between data and picked the variables that were highly correlated to the new dates. That's a target variable. Then I ran my modeling and model evaluation and recommendation. Now, just a brief background of where the study is coming from. Now, the COVID-19 it's caused by SARS coronavirus 2, which was first detected in Wuhan, China. So as a result of the adverse effects in our lives, the WHO classified the COVID-19 virus as a pandemic, and in early December, yes, the Pfizer and the BioNTech COVID-19 vaccine was approved for use in the UK, and according to WHO current website, at least more than 10 million doses have been administered of the coronavirus vaccine. So basically this research takes to look at the effect of or to predict the outcome of new dates as regards the COVID-19 vaccination program. So the rationale is that the COVID-19 data is large, and because of the threat of the pandemic, it requires a real-time analysis of data, and one of the easiest ways to communicate this data to policymakers, healthcare providers, is through the use of visualization techniques, which make to understand this pandemic spread patterns and trend. And government on all tiers are constantly monitoring the pandemic patterns and trends, so as to be able to ensure the continuous operations of economic, business, and educational activities. And COVID-19, like I said, has comprehensive data, so analyzing it's not really easy. So this study presents the COVID-19 data graphically, making it very easy to understand and just basic for people to understand. And in addition, this study will also implement machine learning model techniques in predicting the outcome of new dates, so that the government can help government make more accurate decisions and develop better strategy in combating the fight against the pandemic. Now, the ethical consideration. So this study did not undergo a primary analysis of data. So what it just entails was basically secondary analysis of pre-existing data. So there was no need for interviews, or with this study did not have any direct contact with participants, and Leeds Beckett Research Ethic Committee granted ethical approval for this study. So before I just go to the research and my outcome and discussion, I just want to check through which the links also available here, but let me just show the visualization of the COVID-19 dashboard. Now this is the application is available over the internet and can be accessed from anywhere in the world. The visualization hold the COVID-19 record for all the countries, but this study, like it was the objective, is limited just to the UK, but it has the capability of searching for everywhere in the world. So I go through it now. This gives me an overview, general overview of this is the map of the Europe, and this is the United Kingdom, the population in the UK. It gives me the total number of cases, total number of deaths, total number of hospitalization, total number of ICU patients, as intensive care unit patients, and total number of tests carried out. It also gives me an overview of total number of vaccination, total number of people vaccinated, and the percentage as regards in relation to the population of the UK. So 78% people are vaccinated and 73% have been fully vaccinated. It also gives me the total number of boosters that have been administered. Now this just gives you the trend for the year 2022. So this gives you the trend for the COVID cases, the trend for the COVID deaths, the trend for the hospitalization, the trend for the admission of patients to the intensive care units, and the trend for the vaccination. Rolling over this line graph gives you the actual numbers for each of the months. Then this gives you a comparison of the four variables, that's the COVID cases, the deaths, the hospitalization, and the vaccination. And this just gives us a bar chart presentation of the cases with vaccination. So the cases, the blue is the cases, while the red is the green is the vaccination, and this gives you the bar chart presentation of the COVID dates for each of the months for the year 2022. And this also gives us a trend for the vaccination. Now this application also have the ability to analyze for previous years. So if you take it back just by selecting 2021, so it has given us the trend and pattern for the UK, still on the UK. So because it's selected UK here, so this is the trend for 2021 as regards the number of cases, the number of deaths, hospitalization, admission of people to the intensive care unit for every month, and the vaccination trend, and also a comparison. And this also give us a chart. This is the death charts for the year 2021, and this is the cases and the vaccination charts for each year for the year 2021. Also, it's 2020 same. This is also the trend for 2020. So it's available online, and this application synchronizes daily with our holding data GitHub access. So it has real-time access to update. It updates daily automatically. So I could just check for my country, Nigeria, just to show that it's not limited to the UK. So this is my country flag, and this is the population of my country, and also the vaccination records, the trends. So I could say that previous year, and it gives you a bit of the trends and patterns. So just a review of so this is just the dashboard. It's available online, and also has the ability of aggregated data. So let's just click on it. So it's currently loading up. So this is the aggregated data. So this aggregated data gives you the information about the fully vaccinated, the country with the highest number of fully vaccinated. So it gives you the top 20 countries with the number of fully vaccinated. This gives you the countries the least amount of fully vaccinated individuals, and we can see that it's predominantly dominated by underdeveloped countries. Then also this gives you the country with the highest number of not fully vaccinated individuals. So also this gives you the country with the lowest number of not fully individuals, which is also dominated by underdeveloped countries. And then this gives you the country with the highest number of COVID-19 cases, as the top 20 countries, and also the countries with the highest number of COVID-19 deaths. And these two charts for the cases and deaths are dominated by the United States of America. So this just good. So going back to my dissertation poster, the research outcomes and discussion. So from data analysis for this research, we can say fully well that the COVID-19 vaccination program in the United Kingdom has helped to reduce the COVID-19 deaths. It has also helped to reduce hospitalization, admission into the intensive care unit. So if I could quickly just go back to the UK to just buttress that first point. So for the year 2021, we can see that the year 2021, the month of December had the highest number of cases, but it does not flow with number of dates. So, and the year December, the month of December 2021 also had the highest number of vaccinations. So you can see, so the highest number of cases, highest number of vaccination, and the deaths dropped. So then also aggregated data also shows that underdeveloped countries dominate the list of countries with the lowest percentage of fully vaccinated individuals. So which is also available on this data analysis. So this is the list of dominated by underdeveloped countries, both for the least number of fully vaccinated individuals and also not fully vaccinated individuals. Then also this study, so the visual dashboard can be accessed via the web. Clicking on the link. The link is also available. So it's a web application that's accessible online. And during the machine learning application process, this study observed that this analysis indicates that there's a correlation between the COVID-19 new deaths and also the vaccinations. Now, this study also employed the application of regression machine learning models to be more efficient, and also 6 machine learning models were used for this study. So this table just gives us the 6 machine learning model, which is the SG boost regressor, the random forest regressor, with parameter tuning. This study also used the cat boost regressor, the k nearest neighbor regressor, and the linear regression. So this shows the evaluation when each of these model was evaluation metric was run on each of these model. So this were the result that was obtained. So the mean square error, the root mean square error, the mean absolute error, and the R square value. So when we compare the evaluation of each of these models, we discovered that the random forest regression model was the best performing models as compared to the other 5 models that were used. So this table just gives a comparison of the model performance. So then the conclusion is that the random forest regressor model was the best predictive model, so with the least error, and also it has the least error and also the highest R square value, so which means it was the best as compared with other 5 predictive models. And the random forest regressor should be selected based on this study for use to develop a clinical support system for predicting the outcome of new deaths with the COVID-19 vaccination program. Now further improvement for this research can also be carried out just like limitations. So this study did not consider the application of the booster vaccination data, and also other machine learning techniques can also be used periodically as the data grows. Then for just a quick one for the data preparation process, for the data preparation process as the methodology, so this the process involved was that this study took in 4 data sets, taking the COVID-19 data set, the vaccination data set, the population data set, and the aggregated vaccination data set. So there was cleaning of the data, there was data merging process, because each of the data had a unique country and ISO code, so which each of the data set was merged to form a clean data that was used for the machine learning modeling process. And this is a table. So thank you.